In this section, we'll be talking about relations and functions. So starting off with relations. So before we get into the definition, let's say we have this table that corresponds the number of hours worked to the amount of dollars in the paycheck. So in the left column, we have the amount of hours worked. So 5, 10, 20, and 40. And then on the right, we have the paycheck amount in dollars. So for 5 hours work, that corresponds to a total of a $40 paycheck. For 10 hours worked, $80 paycheck, and so on. So this is actually a relation. We can write this as an ordered pair, where the amount of hours worked is the first coordinate, and the paycheck amount is the second coordinate. And another way that we can write this table out is a set of those ordered pairs. So you can see with this first set, so it's a set, so we use the squiggly brackets on the outside to represent a set. So we have that first coordinate, or the first ordered pair rather, 5, 40. And that second one should say 10, it should say 10, 80. And then we have 2160 and 4320. So each of the first component in the ordered pair represents the hours worked. The second component represents the paycheck amount. And this sort of ordered pairs is called a relation. So that's the definition of a relation. A relation is just going to be any set of ordered pairs. So we have two components. The first component corresponds to the second component. And the set of all the first components in the ordered pair is called the domain, which are going to be considered x values. And the set of all the second components is called the range, which will be the y values. So doing this example here, let's find the domain and range of this relation. So we have -1, 2, 4, 0, -3, 1, and 8, 5. So we want the domain and range. So both of these are sets, so they're both going to be squiggly brackets. The domain is the set of the first elements. So the domain is going to be all of these first elements. So it's going to be -1, 4, -3, and 8. And then the range is going to be the set of all of these second elements. So it's going to be 2, 0, 1, and 5. Okay, so that's the domain and range of that relation. So expanding on that definition of relation, we have functions. So a function is a relation such that each element from the domain corresponds to only one element in the range. So what that means is that no ordered pair can have the same first component with a different second component. So each x value can only go to one y value. So some examples here, let's determine whether each relation is a function. So this first one, we have the coordinates 1, 6, 2, 6, 3, 8, and 4, 9. So since each y coordinate, or each x coordinate only appears once, there's no repetition, that means each x coordinate will go to one y coordinate. So yes, this is a function. And for the next one, we have 6, 1, 6, 2, 8, 3, and 9, 4. So for this one, we have an x coordinate of 6 appearing twice. So this is not going to be a function because the 6 goes to a y coordinate of 1, and it also goes to a y coordinate of 2. So we have one x coordinate going to two different y coordinates, so that is not a function. Last one here, we have 2, -3, 4, 3, 2, -3, -5, 0, and 6, 6. So look for some repetition in the x's. We do have these 2's that are repeating. So originally we might think it's not a function. However, they're both going to the same value of -3. So this relation is a function. Both x coordinates are going to the same y coordinate. Okay, so let's find the domain and range of this function. So the domain is going to be the set of all the first coordinates. So it's going to be every x coordinate. So 2, -3, 0, 5, -4. And for the range, it's going to be the set of all the second coordinates. So 8, -1, 0, -6, and 2. So that is the domain and range of that function. Okay, so there's several other different ways that we can see how a relation is shown to us. The first way is that set of ordered pairs, which we've already done. So I just have an example for each one. So set of ordered pairs, let's say we have F and H here. They represent different relations, and we have the different ordered pairs. The next way is called a correspondence or a mapping. So keep in mind, these all represent a relation, all represent the same thing, just different ways to show them. So for the first one over here, we have a relation of F. So we can see how it's the same one that I wrote above it. We have 1, 2. So the left circle, or the left oval, represents the x coordinates, and the right one represents the y coordinates. So we can see that 1 goes to 2, -2 goes to 4, 3 goes to -1. And for H, we can see that, for example, we have -2 goes to 1 and -2 goes to 0. So we have this -2 going to two different y values, which is a way to represent how it's not a function using the mapping. Okay, next way is a table, which we've seen before. So we have an x column and a y column. So that's saying that for this f here, that 1 corresponds to a y value of 2, -2 corresponds to a y value of 4. So once again, we've seen that before. And another one is a graph, which we've also seen before. We graph them as xy coordinates on the rectangular coordinate system. So we have the coordinate 1, 2, -2, 4, and 3, -1, because they're just x's and y's. And the other way, the last way here, is going to be an equation, which we'll focus on for this next page here. So for relations as equations, so typically when we're dealing with this stuff, we're going to be getting relations given to us as an equation rather than ordered pairs. The solutions to an equation will give us an infinite set of ordered pairs. So for example, we have this equation, y equals 2x. This defines y as a function of x. So we see how when we plug in different x values, it gives us out their corresponding y values. So we know how to graph this by now. We know that it's a linear equation, and if we graphed it, it's in y equals mx plus b form. The slope is 2, y-intercept of 0, so we can graph it right down here on the left side. So we know how to graph it. So technically, all of the line that is being graphed here is an infinite amount of the ordered pairs being plotted, and they're all connected. Okay, so when we have an equation, we get two variables. We have the x and the y. For the independent variable, we say that that is the x, and this can take on any value from the domain. And we can think of this as the input value. And then we have the dependent variable, which we call y. And the y values can be any value from the range. And we can think of these as the output values to the equation. However, for being any value from the range, it is dependent on what x is, hence the name dependent variable. The output depends on the input. Okay, so we already did identifying functions from relations with ordered pairs. That was hopefully relatively simple. Identifying functions from equations is a little bit more difficult. So what we want to do is we want to solve the equation for y. And if we get more than one y value out for a given x value, then that means the equation is not a function. So it's the same definition, it's just a little bit more difficult because it's not as simple as just looking at the ordered pairs. So let's do an example here. Let's determine whether each equation defines y as a function of x. So for this first one, we have y equals x plus 4. So we want to imagine plugging in x values here and seeing if each x value only gives us one y value out. This will be the case. Y equals x plus 4 no matter what x we plug in. If we plug in x equals 2, that'll be y equals 2 plus 4, which is y equals 6. That only gave us one y value out, so this would be a function. Okay, and the next one we have y equals x squared plus 1. So once again, we imagine plugging in values here. We plug in, technically there's an infinite amount of values, that's why I'm not bother plugging them in. If we plug in any value here, let's say we plug in 3 for x, that's going to be 3 squared plus 1, which is 9 plus 1, which is y equals 10. No matter what x value we plug in, we will be getting out one y value. So once again, yes, this is a function. And for the last one here, y squared equals x. So we want to solve these for y. So this one's a little more complicated because solving this for y, we would have to take the square root on both sides. When you take the square root of something like this in an equation, where you're taking the square root of both sides, you don't just get y equals the square root of x, you get y equals plus or minus the square root of x. So with that being said, no matter what value of x we plug in, we're going to get a positive answer and a negative answer. So this means that this is not a function because we get more than one value of y for each x that we plug in. Okay, so kind of a hint for these ones, if there is a y squared, or technically y to any even power, then it will not be a function. Okay, for the next thing, we're going to identify functions from their graphs instead of from their equations. So not every graph we see is going to represent a function. So we already know that each x value can only correspond to one y value. So what that means is we can use what's called the vertical line test. Because if one x value corresponded to more than one y value, if we plotted them on a graph, they would be on top of each other. So this is where the vertical line test comes into play. The vertical line test says that if any vertical line intersects the graph more than once, it is not a function. So we have to imagine creating a vertical line over the graph. If it intersects it more than once, it is not a function. That means that at least one x value corresponded to more than one y value. So let's do these examples. So for example, let's use the vertical line test to identify which one of these graphs is a function of x. So this isn't multiple choice, we're going to do them all individually. So for the first one here, we have for A, this football shaped looking graph. So if we draw a vertical line and we recognize that it intersects at two different points, since it intersected at more than one point, that means this is not a function. So it failed the vertical line test, so it is not a function. For the next one, it is a linear equation. So drawing a vertical line anywhere, we can see that it only intersects it at one spot. So this is a function. And for C, for the left here, looks kind of like a U. So drawing a vertical line anywhere, we see that it intersects only one spot, so we see that this is a function. For this one on the right, similar shape to the one that we just did, but on its side. So when we draw a vertical line, this one will intersect it at two spots, so this is not a function. Okay, so that's the vertical line test, relatively simple. If a vertical line drawn anywhere intersects more than one spot on the graph, that graph is not a function. Okay, next thing here, it's actually the last thing. It's determining domain and range from graphs. So we've seen that domain is the set of all x values, and the range is the set of all y values. And when we're given the relation as ordered pairs, it's a lot easier to determine the domain and range. But now we're going to be determining them from graphs, and it'll be a little bit more complicated. So for graphs, for the endpoints on the graphs, we sort of have three options of what it can look like. We can have a closed circle, an open circle, or arrows. So if we have a closed circle, So a closed circle meaning a filled in circle. This means that the graph stops at that point, and that point belongs on the graph. If we have an open circle means that the graph stops at that point. However, it does not belong as a point on the graph. It gets infinitely close to that point, but technically it never gets there. And the last one is an arrow. An arrow represents that the graph extends indefinitely in that direction, wherever it's pointing. So it's just going to keep on going in whatever direction that is. Okay, so let's see an example here. So let's say that this is some graph. We can see that we have an open circle right here on the graph, and then we have an arrow right here. So the open circle on the left means that that point is not included, but it gets infinitely close. And then this arrow on the right means that it's just going to keep on extending in that direction forever. So the notation that we use to represent the domain and range, we have two options. We can use interval notation or set builder notation. So I'm going to focus mostly on interval notation, but I figured we'd at least mention set notation while we're here. So for interval notation, it's actually going to look similar to an XY coordinate, except it is not going to be an XY coordinate. So we're going to be using parentheses, or we're going to be using brackets. So parentheses are going to indicate endpoints when they are not included, and brackets are going to indicate endpoints when they are included. So for interval notation, we always have to write the smaller number first, and parentheses are always used when we have a negative or positive infinity. For set builder notation is going to be when the elements are described but not listed. So it's going to be written like this, where it's squiggly bracket, the brace representing a set. It's the set of all x values such that whatever the description of the x's is. So this could be something like set of all x's such that x is between -1 and 5. So that would be the description of an example for domain or range for here. In this case, domain, because I put an x. Okay, but like I said, I'll be focusing on interval notation. Okay, so for the domain, what we're going to do when we are finding the domain, we have to remember it is the set of all the inputs, meaning it's where the function exists in regard to the x-axis. For the range, it's the set of the outputs, which is going to be the set of the x values for the y-axis. So when we're determining the domain and range, what we have to do for the domain, we're going to scan left to right. And for the range, we're going to scan bottom to top. So we go in that direction because left to right is obviously horizontal, meaning the x-axis, so it's the domain. The range is vertical, y-axis, so bottom to top. We go in that certain direction because that means the values are going to be getting larger. So let's use each graph here to find the domain and range. So for the first one, we have this function. So what we're going to do for the domain, I'm just going to label these D and R for domain and range. Domain, we scan left to right. So scanning this left to right, the function starts existing at -2. Since there is a closed circle, it's filled in. That means we use a bracket. So it's going to be from -2, comma, and then it goes until x equals 1. So that's where it stops for the x values, -2 to 1, and that also gets a bracket because it's a filled in circle, so we're including those endpoints. So you can see how it kind of looks like an xy coordinate, but it is not an xy coordinate. Those are just the x values. It's read as -2 to 1. For the range, we're going to scan bottom to top. So it starts existing right here. We have to remember we're using the y values only. So that's at y equals 0. It's a filled in circle, so it's a closed bracket. And then it stops right here at 3. That is the y coordinate for where it stops. So the range is from 0 to 3. So domain, x values only, you're only looking at the x-axis values. Range is y-axis only, so only the y values. Okay, and now for part B, or graph B on the right, doing the domain, scanning this left to right. The domain is going to be starting right here at -3 and stopping here at +2. There is a open circle at -3, so this one gets a parenthesis. So from -3 to 2, 2 gets a bracket because of the closed circle. So that's the domain. So that's saying the function exists between the x values of -3 to 2, not including -3. And now for the range, bottom to top. So it starts existing right here at 1, and then it goes up to 2 right up here. So that's going to be from 1 to 2, where we are not including the 1 because it was an open circle. Okay, for C, for the domain, going left to right, it goes from 2 to 1 with a bracket on, or -2, sorry, -2 to 1, bracket on -2, parenthesis on 1 because it was an open circle. For the range, we're going to be going bottom to top. So it goes from right here to right here, from 1 to 5. It is directly cutting through that 1. That means we include it with a bracket. So 1 to 5, and both of them get brackets. Because at 5, it was a closed circle. Okay, make it a little bit harder here with part D. Part D, for the domain going left to right here, there is an arrow this time. That arrow is going to the left. So that's going to actually start from -infinity. That means it keeps on going to the left and never stops. So that means it goes all the way, starts from all the way from -infinity with a parenthesis, always parentheses on the infinities. And it goes right up here to x equals 4. Closed circle, we put a bracket. Okay, and then for the range, bottom to top, so it starts right here. That corresponds to a y value of 0, so we include it. And then it goes up to, there's an arrow. It's going to the left, but technically that's still going up, so that's going to actually go to infinity. Okay, so that's the range from 0 to infinity. And we'll do 2 more. For E, we have a circle. So the domain for this is going to be scanning it left to right. So it starts right here and goes to right here. That looks like it is from -2 to 2. And we're going to be including both of those because it's directly cutting through it. And the range, scanning bottom to top, goes from here to here. That is also going to be -2 to 2. Okay, and then the last one here, domain from left to right. So we have arrows for both of these. So we're only interested in the fact for the x direction, the horizontal direction. So the one on the left here is still going to the left. So that means it's starting from -infinity. And the one on the right is still going to the right. So it's going to be from -infinity to +infinity for the domain. And then for the range, bottom to top. So these arrows down here means it's starting from -infinity. And it's going right up here, which is a y value of 4. It's cutting through it, so we put a bracket on it. Okay, so that is it for this section.